We're doing lesson 9.2b, equations and tables. The essential question is what we're going to be doing. How can you recognize equations in data tables? So data is just information. You're going to be looking at tables, and then you're going to figure out what equations are in there. In lesson 9.2a, you learn to use equations and insert data into tables. In lesson 9.2b, you will learn to recognize equations given the data that's already in the input-output tables. So you're kind of doing the opposite. So let's go ahead and take a look at what we're doing. So we're being given data in a table. We've got to find the equation that it represents. So here's the problem we're presented with. Tyshawn attends Liberty Prep Academy to help him prepare for college. Part of his curriculum includes football instruction as he plans to get a football scholarship offer. The table below represents the number of weeks Tyshawn has attended Liberty the past fall. Find an equation that represents how the data in the given table can be represented. So in the first column, this is the X. This is the number of weeks that he's been at Liberty. The second column, the Y, are the number of games that he's played. So the first week, number of weeks he's been there, and then the Y, number of football games that he's actually played. So what are we going to do with this data? Here's the data again. Here is the steps. You need to write these down. Step 1, compare each value of the X column to its matching pair in the Y. So we compare the 1 to the 0. These two are a pair. They go together. We compare these two. These go together, and so on. Step 2, decide what must happen to the X, this one here, for it to become Y. Are we adding? Are we subtracting? Are we multiplying? Are we dividing? Step 3, make sure that you can use the same operation to each X for it to become Y. So what happens for 1 to become 0? Are we adding? Well, obviously not. We're not multiplying. We're subtracting by 1. So 1 minus 1 is 0. All right, step 3, make sure that you can use the same operation to each X for it to become Y. All right, so is 2 minus 1? Yeah, 2 minus 1 is 1. 3 minus 1 is 2. So we're doing the same thing. If there was a time where we couldn't do the same operation, that wouldn't be an equation we can use. And then step 4, write the equation from Y. So Y equals what? In this case, Y is 0, X is 1. We would say Y equals, because this is what we're doing in step 4, Y equals what? Y equals X minus 1. And that works for this whole table. 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 1 is 2, and so on. This is the equation for this problem. Y equals X minus 1. All right, so let's go ahead and try another. A student is saving money to buy a gift card for his sister. Below are the number of weeks he has saved and the total amount of savings each week. And again, we have to find an equation that represents the data in the table below. We've got the X and the Y. What are we doing to the X to make it become Y? Well, let's take a look. So 1 to 8, I must be adding 7, right? Because 1 plus 7 is 8. So 2 plus 7 is going to be, wait a minute, 2 plus 7 is 9. That's a 16, so I'm not adding 7. That won't work. What else can I be doing? I can't be subtracting. I'm not dividing. What about multiplying? 1 times 8 is 8. What about 2 times 8? Does that work? Well, it does. 2 times 8 is 16. Will it work for everyone? 3 times 8 is 24. Yes. 5 times 8 is 40. 10 times 8 is 80. Okay, we found it. It works every time. So y equals what? Step 4, I'm writing from y. Y equals what? Y equals x times 8. X times 8. So each time we're going to write an equation from the y, and we're going to write out what it is. Last one we're going to do here. The weekend is trying to determine how much he is paying the IRS in taxes. He's looking at his earnings and amount left after taxes for the last 5 years. So, first column, the X, this is how much money he's earned. And then the Y is how much money he has left after taxes. So what are we doing to the X to make it become Y? Let's see, let's see, 4 minus 2 is 2. Does that still work for the next one? 8 minus 2 is 4. No, that doesn't work. Okay, I'm not subtracting. I'm obviously not adding because it's getting smaller. What about if I divide? Let's try 4 divided by 2 is 2. Yes. Okay, it works. 8 divided by 2 is 4. All right, it works for 2 of them. What's 2 divided by 2? 2 divided by 2 is 1. 12 divided by 2 is 6. Yes. 3 divided by 2 is 1.5. Yes. Okay. So I'm going to write my equation. I write it from the y. Y equals... What am I doing to x? Every time I'm dividing x by 2. Y equals, and you can write it however you want as long as it's showing it's being divided by 2. Y equals x divided by 2. And that's it. We are done with lesson 9.2b.